Dear viewers, this video is presented to you by Rajiv Institute of Technology, Hassan, Department of VLSI Design and Technology. I am Mrs. Ambika K, working as Assistant Professor. Under the section of Digital Logic Circuits Lab, in this video you are going to learn the experiment number 8. Realize the following shift registers using the IC 7495, and the shift registers that you are going to learn here is ring counter and Johnson counter. The shift register is a sequential circuit wherein upon the occurrence of each clock pulses, the contents of the registers are going to be moved either in right direction or in left direction. So this working can be realized with the help of an IC that is 7495. So IC 7495, it is basically a 4-bit shift register which is capable of shifting its contents to the right direction. So that's why it is going to have 4 input terminals, that they are D3, D2, D1 and D0. So these are the 3 input terminals. Similarly, 4 output terminals, Q3, Q2, Q1 and Q0. Apart from that, a shift register can be made to operate in 2 modes. One is parallel mode, another one is serial mode. Serial mode of moving the contents means one by one the contents are supposed to be moved from one bit to another bit, or one flip-flop to another flip-flop. But in parallel mode, simultaneously all the 4 inputs are given and we are going to get the 4 outputs. So that is parallel mode. For the mode selection, we are having the input terminal M. If M is equal to 0, serial mode will be chosen. If M is equal to 1, then parallel mode will be chosen. And also 2 clock pulses. Provision for 2 clock pulses is provided, clock 1 and clock 2. One clock is for serial mode of operation and another clock is for parallel mode of its operation. First one is a ring counter. 7495 can be visualized as a ring counter. If you wanted to design a 4-bit ring counter, then we are going to have 4 different states. 100 is the first state, 0100, 0010 and 0001. So for 4 clock pulses, 4 different states it is possible to obtain. If we are having a 5-bit shift register, then that ring counter is going to produce 5 different states. Since 7495 is a 4-bit shift register, there is a scope for the generation of 4 different states. And in order to make 7495 to work as a ring counter, the logic diagram is going to show the connections. The only connection that is required here is the Q0 output has to be connected to the serial input DS. So one pin is connected to the 10th pin. So at the beginning step, we have to load the ring counter with its initial value. So for that, we have to keep the value of mode should be kept at 1. And the first value is loaded into a shift register. Its first value is 1000. After loading the data, the mode has to be changed to 0. So in the second clock pulse, mode should be kept at 0 and apply the clock pulse. Then automatically the contents will be shifted to the right direction. So the next state is 0100. A third clock pulse is given, the state will be 0010. For the 4th clock pulse, the state would be 0001. For the 5th clock pulse, again the same counts are going to be repeated again and again. So for a 4-bit shift register, it's possible to design a 4-bit ring counter. The next kind of a counter that can be designed using the IC 7495 is Johnson counter. So in Johnson counter, it is possible to generate 8 different states, and the extra connection that is required here is the output Q3. It should be connected to the serial input through an inverter. Through a NOT gate it has to be connected. So its designed after the designing procedure in order to observe the 8 different states of Johnson counter. For the realization of ring and Johnson counter, we are making use of the IC 7495. 7495, this is mounted on the IC socket and it is a 4-bit shift register. So default it is going to move or shift its contents to the right direction. So it is a 4-bit shift register. In order to observe the performance or the working of the IC 7495 as a ring counter, let us switch on the digital IC trainer kit. Let us observe the inputs and output terminals of the ring counter. So it is having 4, since it is a 4-bit shift register, it is going to have 4 input bits D3, D2, D1 and D0. D3, D2, D1, D0. And this shift register can be operated in 2 modes. So that's why we are having a mode control bit, that is M. If M is equal to 0, that is in serial mode. If M is equal to 1, it is in parallel mode. And it is having 4 output terminals Q3, Q2, Q1 and Q0. And also it is having the serial input line that is called as DS. So according to the truth table, according to the logic diagram that was shown, the circuit diagram has been built. Now let us give an example to illustrate the working of the shift register 7495 as a ring counter. In order to know the working, let us first put the shift register in its parallel mode. So make M is equal to 0 and this shift register has to be loaded with an appropriate data. We are giving the data here as 1000. The data what we are providing to this shift register is 1000 and we have kept the mode as equal to 1 because it is in parallel mode. Parallelly we are loading the data and let us apply the clock pulse. As soon as the clock pulse is applied, whatever the data we have loaded, that is going to be appear along the shift register. We have loaded the data 1000, the same is going to be reflected on the shift register also 1000. Now this data should be moved to the right direction because it has to work as a ring counter. So let us change the mode to 0 because serially now the data has to move and give the clock pulse. You can observe now the data is 0100. For the next clock pulse 0010. For the next clock pulse it is 0001. Let us give the 5th clock pulse. For the 5th clock pulse again it has started to rotate the same states 1000. 0100, 0010, 0001. So since it is a 4-bit shift register, it is going to take 4 clock pulses to show different states. At the 5th clock pulse, the same states are going to be repeated again and again. So this is the working of 7495 as a ring counter. According to the logic diagram, the Johnson counter, it was rigged up, and the Johnson counter, for its development, for the circuit development, we require 2 ICs. One is 7495, it has been used here. Another one is 7404. Let us switch on the trainer kit and observe the output. First we have to load the IC 7495 with a proper input. The inputs that we are going to take here, they are D3, D2, D1 and D0, and we have given the value as 1000 and the mode control, it has to be equal to 0 because we are loading the data 1000 into a shift register in parallel mode. So that's why mode select input should be equal to 0. And the Johnson counter, if we are using 7495 for the realization of Johnson counter, then it is going to give us 8 different states because 7495 is a 4-bit shift register, 4 into 2. So usually we are going to get 8 different states from this Johnson counter. Let us apply the clock pulse. 1000 is going to be loaded into the shift register. Now change the mode to 0. If M is equal to 0, it indicates serially mode. So first we have to in parallel mode, the data should be loaded into a shift register. After loading the data,
change the mode to serial, means make M is equal to 0. Now apply the clock pulse. You can observe the next state is 1100. Third clock pulse 1110. This is the third state. Fourth clock pulse, the state is 1111. For the fifth clock pulse, it is 0111. For the next clock pulse, 001011. Next clock pulse, for the seventh clock pulse, it is 0001. For the eighth clock pulse, we will get the value as 0000. Let us give the ninth clock pulse. So here the states are going to be repeated because the first state was 10000. The last state is going to be 1111. So at the ninth clock pulse, the states are going to be repeated. So we can say that a 4-bit Johnson counter is going to give us 8 different states. At the ninth clock pulse, the same states are going to be repeated. So here we have loaded initially the data 1000. From that data we can get 8 different states. So this is the realization of 4-bit Johnson counter.